Hi there, welcome back. In this video, we're going to find any inflection points that the graph of f of x equals 2x minus 3x to the 2/3 may have. And remember that the inflection point is where the graph changes concavity. And concavity, that information is found by using the second derivative. So we're going to find the second derivative of the function first, and then solve accordingly. So first things first, first derivative, that's going to be 2 minus 2x to the negative 1/3, just using the power rule, and then taking the second derivative. Derivative of 2 is 0 minus, now we have 2 times negative 1/3 x to the negative 4/3, and that looks like 2/3 x to the negative 4/3. Now, that might be a little bit difficult to see what's happening, so I'm going to rewrite this in terms of positive exponents, which just means writing the x to the negative 4/3 as x to the 4/3 in the denominator, and we can immediately see that this is undefined when x equals 0. So that is definitely a candidate. But one thing we have to check is, is it a candidate? Because if it's not defined in the original function, there's no point to even talk about there. And looking at the original function, the domain is all real numbers because the 3 in the denominator indicates a cube root, and it's positive 2/3 power. So that means x equals 0 will be, we can plug in x equals 0. The value of f of 0 is defined. So that means 0 is definitely a candidate for being a point of inflection. So let's take a look. So we're going to make our sign graph for f double prime. We have to consider x equals 0 as a possible place where the graph changes concavity. And we're going to do our intervals. So remember, the intervals are going to be negative infinity to 0 and 0 to infinity. There's no other possible places. And we're going to do our test numbers. I'm going to say -1, and I'm going to say 1. And then we're going to substitute those values into the second derivative. So you have 2 over 3 times -1 to the 4/3. Well, -1 to the 4/3, cube root of -1 is -1, raised to the 4th is 1. So you have 2 over 3 times 1, which is 2/3, which means concave up. So it's concave up to the left of 0. If we plug in 1, this is interesting. We have 2 over 3 times 1 to the 4/3. Well, 1 to any power is 1. So this is also 2/3, which means also concave up. So this graph does not have a point of inflection, because it is not changing concavity ever. It is always concave up, except possibly at x equals 0, where it kind of just levels off. So there is no point of inflection. And there is the graph of the function, and as we can see, it comes up. There is a sharp corner at 0. It is concave up to the left. I don't think I included enough of the graph there, but it is concave up there. And then to the right, it continues to be concave up. It just comes to a sharp point in the middle there at x equals 0.